I am T. Kavitha, Assistant Professor, Department of Mathematics. Today's topic is correlation in Mathematics and Statistical Computation paper. Correlation. The word correlation is used in everyday life to denote some form of association. We might say that we have noticed a correlation between foggy days and attacks of busyness. However, in statistical terms, we use correlation to denote association between two quantitative variables. We also assume that the association is linear, that one variable increases or decreases a fixed amount for a unit increase or decrease in the other. The other technique that is often used in these circumstances is regression, which involves estimating the best straight line to summarize the association. Correlation coefficient. The degree of association is measured by correlation coefficient denoted by R or gamma. It is sometimes called a Pearson's correlation coefficient after its originator and is measure of all linear association. If a curved line is needed to express the relationship, other and more complicated measures of the correlation must be used. The correlation coefficient is measured on a scale that varies from +1 through 0 to -1. Complete correlation between two variables is expressed by either +1 or -1. When two variable increases as the other when one variable increases as the other increases, the correlation is positive. When one decreases as the other increases is negative. Types of correlation. The scatter plot explains the correlation between the two attributes or variables. It represents how closely the two variables are connected. There can be three such situations to see the relation between two variables. Positive correlation. When the values of two variables is move in the same direction so that an increase or decrease in the value of one variable is followed by an increase or decrease in value of the other variable. Negative correlation. When the values of the two variables move in the opposite direction so that an increase or decrease in the value of one variable is followed by decrease or increase in the value of the other variable. No correlation. When there is no linear dependence or no relation between the two variables is no correlation. Correlation coefficient formula R is equal to, this is the formula for correlation coefficient. R is equal to n into summation of xy minus summation of x into summation of y divided by root of n into summation of x square minus summation of x the whole square into n into root of into n into summation of y square minus summation of y whole square. The other formula is summation of x minus x bar into y minus y bar divided by n into sigma x and sigma y. This is the example form sum for this. Calculate the correlation coefficient between x and y. Comment on the relationship. X is 2, 6, 8, 10, 12, 16. Y is 4, 12, 16, 20, 28, 32. First we write the correlation coefficient formula. N into summation of xy minus summation of y summation x summation of y divided by root of n into summation of x square minus summation of x the whole square into root of n into summation of y square minus summation of y the whole square. First we write x 2, 6, 8, 10, 12, 14, 16. The total value is 56. Then next we have to write y 4, 12, 16, 20, 28, 32. Sum of this is 1. Summation of y is 112. Next we multiply the values x and y. Xy 2 4s are 8, 6 12s are 72. Multiply all the x and y, add these values, we get summation of xy is equal to 1312 and summation of x square. We take the values of x square of x. 2 square is 4, 6 square is equal to 36, 8 square is equal to 64, 10 square is equal to 100, 14 square is equal to 196, 16 square is equal to 256. Add all this, we get summation of x square, that is 656. As like this, we find out y square. Summation of y square is equal to 2624. Substitute all these values in formula. Here n is equal to 6. 6 into 1312 minus 56 in 112 divided by root of 6 into 656 minus 56 whole square into root of 6 into 2624 minus 12544. We get the value 1.0001. Here the nature of this correlation is perfect positive correlation. Thank you.